Okay, 4.6. Natural log function integration. So this is pretty simple because you have been using natural log to integrate for a while. This is just kind of focused on natural log integration for one section. Okay, so you had it on the quiz, and I put absolute value on everybody's answer. So I said before, it's okay if you didn't put absolute value, but from now on, I show you that you need to put absolute value, you need to put absolute value. So this is the important part. You have to put absolute value inside a logarithmic function. I feel like I spelled that wrong. I think there's no I there. Logarithmic. Anyways, please make sure you put a absolute value inside a log is the thing. All right, so let's go ahead and look at this question. Again, we're going to try to do it with u sub. What is the u part? 4x minus 1. What is du? 4 dx. Okay, so then 1/4 du is dx. So then we're going to change this question to 1/4 integral 1 over u du. Okay, what's the integral? Huh? ln, natural log. U plus c. So this is 1/4 natural log absolute value 4x minus 1 plus c. Okay, very easy. You've been doing that. Just a reminder, please put absolute value around whatever is inside the natural log. All right, really quickly practice this one. Okay, a lot of you already have the answer. It is negative 1/5 natural log absolute value 2 minus 5x plus c. All right, let's look at a different kind of question. Find the area of the region bounded by the graphs of this equation, the x-axis, and the line x equals 3. What does area of a region mean? Integral. Okay, area always means integral. So they want this equation. I don't know how that looks like. I'm going to randomly draw it. X-axis and the line x equals 3. Let me see how this graph actually looks like.
I mean, it ends at 0, 0. So like.
Yeah, but they should still give you a starting point. So I think they probably just meant y-axis. They didn't say it. So from 0 to 3. Okay, go ahead and set it up. Remember that, they know you can do integral. It's just, can you show them that you can do it by setting it up? So set up the integral with the correct limits and then integrate. All right, so make sure you set it up correctly. 0 to 3 of x over x squared plus 1. Don't forget dx. The answer is 1/2 natural log 10. All right, let's try some other one. These are kind of similar. Let's do something that's a little different. Try this one. Okay, the answer is natural log absolute value x cubed plus x plus c. Okay. Try this one then. Okay, this is easy for you guys. Natural log absolute value tangent x plus c. All right, we're ready to move on to harder ones. Okay, this one. Let's think about it. What would you make u?
X squared plus 1.
Okay, let's say you make this u. That's x squared plus 1. So what is du?
2x.
2x dx. can we get to the x squared plus x plus 1?
Yeah, eventually, if you want to.
How?
If you have the desire.
I can fix this part. I can't.
Square.
Can you just use the u from the
Oh yeah, yeah. Let's do that. That's
It seems quite scary what we're trying to do there. I don't think this is. It's not a. Yeah, some animals are gonna die there. No. So this is a question where if we cannot do. Kind of the old things that we've been doing and we had to kind of like piece everything together, it's a bad sign that, maybe this is not the way you should do it. So this is where you got to recognize some of these patterns. First, the degrees are the same. When the degrees are the same, we are going to do long division. Okay, recall. When the degrees are the same, basically, what happens is if I pick this one as u, usually, du is going to be 1 degree less. Hold on. Du is going to be 1 degree less, so then there's no way to get to another x squared. So when the degrees are the same, we're going to do long division. You have a question?
Can you do like x squared plus 1 over x squared plus 1 plus x over x squared plus 1? I split it up into 2 fractions.
Yes, it would be the same as doing the long division. Yes, you're right.
That's visually better.
Okay. Actually, I think Taya's way might be a little bit better for this case. Okay, so what she was saying is rewrite this problem. So if you rewrite this problem as x squared plus 1 plus x over x squared plus 1, you can split it. Remember, when you split it, it has to be a common denominator that's given to both, okay? So that means x squared plus 1 over x squared plus 1 plus x over x squared plus 1. That's okay. Good. So basically, we did long division the shorter way. And then integrate that. Okay, so that's going to be 1 dx, right, plus this part. This part, do you guys know how to integrate?
Yes.
Yes.
U sub.
You sub.
All right. Go ahead and try this one. Okay, the answer is x plus 1/2 natural log absolute value x squared plus 1 plus c. All right, let's try another one similar. You can use long division or TS method. It's the same. It's basically another way of doing long division. I'm very glad you saw that. Thank you. I learned something new today too. Okay, so go ahead and try. Try this one. Let me know when you're done. Okay, 1/2 x squared minus natural log absolute value 2x plus 1 plus c. All right, next one. Okay. So these are just some kind of tricks to solve this. Okay, what should we do? We could FOIL, but I don't think it's gonna make it better.
But we could.
You could, of course, you can do anything you want.
It's highly recommended.
Which part?
We just used u. X plus 1.
X plus 1. Then du is dx.
Then you multiply by
Perfect.
I need to get this 2x.
Yeah,
X
then you
equals
use
1 minus.
Times
Wait,
2,
wait, wait.
and then you
X equals 1
multiply
minus
by
2. X equals 1 minus
Subtract
2.
it over.
U minus 1, right?
No, 1 minus u. What? Oh, yeah, that's what
You
it
minus
is.
And then
multiply everything by 2.
multiply everything by 2. Because I want a 2x. So 2x is equal to 2 times u minus 1.
2 minus 2.
2u
Oh,
minus 2.
never mind.
Okay. I think we got everything. Is everybody following?
Yeah.
Okay. We're ready to substitute in. So this is, the 2x is the 2 times u minus 1 part. The u is x plus 1, so this is u squared. We have a du. Okay, it's much easier if we just always, we are going to split it up, but it's much easier if we always just throw that coefficient in the front. You really don't want it to come along in your integration. It just makes things a lot harder.
But how do you know when you can do that?
As long as it's multiplied to the whole thing, you can always take it out. If it's just 2u minus 1, of course you cannot take the 2 out. What?
That would be killing me.
I don't know what animal, but it's something is wrong. Okay. Now we need to split them. Yes, we need to split them. U over u squared minus 1 over u squared du.
U minus 1 over. Wait, you have to do the.
Oh.
Simplify.
No.
1 over u minus 1 over u squared du.
That is.
Yes, question.
Just do minus integral of that.
Yes. You basically, because I put 1 du at the very end, that just means the whole thing is being integrated. So then, go ahead and integrate. Remember that you have a 2 that's slapped on at the beginning. So make sure you do multiply everything by 2. So what I try to do to remind myself is I always draw a big bracket or big parentheses to remind myself I gotta multiply that 2 to everything. Okay, so the answer is 2 natural log absolute value x plus 1 plus 2 over x plus 1 plus c. Okay,
Oh, I got it right.
next one. Please be careful of your coefficient. A coefficient is a very annoying thing. Throw it in the front. Yes, okay. So u is 2 minus 3x. du is minus 3 dx. So minus 1/3 du is dx. Okay, we just want the x. That means I'm going to have to change this. U minus 2 divided by negative 3 is x. Okay, all right. Negative 1/3 goes in the front. I have a u minus 2 over negative 3 times 1 over u squared du. That's too complicated. I'm going to take that negative 3 in the denominator outside as well. So that's 1/9. U minus 2 over u squared du. Now that's clean. So I want to integrate when it's cleaner. Okay, so this is going to be 1/9 integral of 1 over u minus 2 over u squared du. Okay, 1/9 in the front. Natural log u minus 2, plus u to the negative 1 plus c. All right, now plug it back in. 1/9 natural log 2 minus 3x plus 2 over 2 minus 3x plus c. That is in parentheses.